The second way that thermal energy moves around is by something called convection. Convection is what happens when warmer, less dense fluid floats upward and cooler, more dense fluid sinks downward. Fluids are types of matter that can flow or move around, so both liquids and gases can do this. For example, the air does this constantly. If I release milkweed over a heater, I can see it ride upward on the rising warm air. If I look up above a large fire, I may notice the leaves of a tree blowing violently in the updraft, an upward blast of wind from the rising warm air that has been heated by the flames. You see, convection is not like conduction, where molecules mostly stay in place and spread their energy by bumping into other molecules. Rather, with convection, these molecules just up and move. They float away to a new location and bring their thermal energy with them. So, how does one minimize heat loss by convection? Well, by creating sealed or closed systems where fluids cannot flow in or out. For instance, if I fill a thermos with hot soup and leave the lid off, convection will carry the warm molecules out of the thermos and cooler molecules will take their place. My soup will cool much quicker than if I had firmly sealed the lid in place. So again, to stop convection, don't let those fluid molecules flow out or in. Create a closed or sealed system. And now to the final form of heat transfer. Radiation. You see, in conduction and convection, molecules are bumping into each other or flowing around, but in radiation, thermal energy is moving by electromagnetic waves. Now, an amazing thing about radiation is that it does not require matter to move. So it can travel right through the emptiness of space, or right through that vacuum that engineers worked so hard to make. Now, it's obvious that the sun is giving off radiation. Think about it. We put on sunscreen to protect ourselves from the harmful rays. But it's less well known that all objects are giving off some electromagnetic or thermal radiation. That's right. Look around you right now. Everything you see is giving off some thermal radiation. And the warmer the object is, the more energy that radiation will carry. For instance, when we look at a locomotive, we see something like this. But if we could see all the thermal radiation, it would look quite different. Don't believe me? Just look at this image of a locomotive taken with a thermal imaging camera. The bright spots are the parts of the train releasing more energetic thermal radiation, while the darker spots are releasing less energetic thermal radiation. So how does radiation transfer thermal energy? Well, when energetic thermal radiation hits the molecules of an object or substance, guess what happens? That's right, the molecules speed up. So what is the most effective way to stop thermal radiation? After all, if it can even travel through a vacuum, it must be impossible to stop, right? Well, no. You simply have to bounce the wave back. Materials that are reflective to electromagnetic radiation will turn that energy around and send it back where it came from. Hence the reason why windshield reflectors, thermoses, and many other objects are shiny and reflective. So let's put it all together and come up with the ultimate plan to beat the heat. Number one, how you gonna stop conduction? Well, just stop those molecules from bouncing into each other by using insulators, or better yet, a vacuum. 2, convection. How are you going to stop those fluids from flowing in and out? Well, you've got to create a closed system. And 3, radiation. How are you going to stop those electromagnetic waves? Just bounce them back where they came from with reflective materials. Have a great day, keep it cool, and as always, Stay curious, my friends.